Hello, welcome aboard to flight 1033C. This is your captain Diana speaking, and with me is my co-pilot Vanina. Please remain seated the entire flight. If you have questions, use the chat box to type in your question and my co-pilot will answer you. Flight destination, test review 2. Duration is approximately 2 hours. We will not serve any refreshments or snacks during the flight, but feel free to get some from your kitchen. We have a clear sky today and we are ready for takeoff, so enjoy your flight. Let's go to the first slide. I hope everybody can hear me loud and clear. You can raise your hand or type into the chat box if you have any issues. And I hope this time we're not going to have complications like last time. So this is question number 1. I hope everybody was able to print out their packets from Blackboard. Question number 1 says solve the equations, so there's going to be a couple of them. This looks like the factoring problem to me, so from the factoring section. And this is an equation. It does not have a coefficient, so in academic systems you might learn a different method of factoring than I am showing today, but I like this factoring method because it's 100% safe to use. You will always get the correct answer, whereby by other methods like the trial and error method, it takes a lot of time. So I'm using the Colombian method just in case anybody is wondering. So if we have a factoring problem where there is no coefficient in front, so the coefficient is actually an imaginary one, we have to write 2 empty sets of parentheses. Then we square root our x squared term, which will give us an x and an x, because remember when you multiply these together using FOIL, you should end up with x squared again. So an x times an x is x squared. Then bring down your first sign, which is a positive. Multiply the 2 signs together. A positive times a negative is a negative to give you the second sign. And then use the last number without the sign. You can ignore the sign. That's why I like this method too. You don't have to worry about your signs anymore once you use the bring it down and multiply together rule. So look at the last number and find 2 factors of this number. When you have different signs, the factors must subtract to give you the middle number. So which factors of 50 would subtract to give me 5? The 2 factors that I found are 10 and 5. So 10 times 5 is 50 and 10 minus 5 is 5. That's how I know that these are the correct factors. Always use the larger number first, so your sign's gonna match, and the smaller of the 2 factors goes in the second parentheses. Remember, we used to have an equal to 0 at the end, so we cannot forget about it, because this means that each part that we found, each factor, we have to set equal to 0 individually. So x plus 10 equals 0, and also x minus 5 is equal to 0. We are solving on both sides for x, so let's start with the left side. Subtract 10 and be careful with the signs. Subtract 10 from both sides. This side it's gone away, and 0 minus 10 leaves us with just negative 10. Then on the right side, x by itself, so we would add 5 to both sides. And on the left side it cancels out. On the right side, 0 plus 5 is 5. So our answer to this factoring problem, and you can write the solution set like this, is -10 and 5. This actually is B on your answer key, on your packet, if you printed it. Are there any questions so far? No questions, Vanina? Okay, so we can move on to the next question. This is another factoring problem, but in this one, as you noticed, there is a coefficient in front of the squared term. So our first step usually is to look for a GCF, which means greatest common factor. And if I look at the 4, the 12, and the 8, I notice that they all have a common factor, a greatest common factor of 4. They are all divisible by 4. So what I'm going to do first is I'm going to take out the GCF, which is 4. I'm dividing each term by 4 and rewrite my problem. So 4d squared dividing by 4, I'm left with just 1d squared or d squared. 12d divided by 4 leaves me with 3d, and 8 divided by 4 leaves me with 2. All that is equal to 0. Now I'm going to get rid of the 4 because there's no variable involved, so I'm going to divide this side by 4 and this side by 4, so I can eliminate the 4. On this side is just 1, and I don't really need it because I still have something else there. And on the right side, 0 divided by 4 still leaves me with 0. So what I did was I just showed you a mathematical way of eliminating the 4. And now it looks like the previous problem, this is a factoring problem with a coefficient of 1. Remember, there's an imaginary 1. So again, we write our empty sets of parentheses. We square root the first term, the d squared. We split it in 2 pieces, so we get a d and a d. And then we bring down the first sign, which is a positive. We multiply the 2 signs together to give us the second set, so a positive times a positive is still a positive. And then we use the last number, in our case is 2. We find the 2 factors of 2, and if you have the same signs in here, 2 positives or 2 negatives, then the factors of 2 must add to give you the middle number, the middle term number, which is 3, right here. The factors of 2 that will add to give me 3 are 2 times 1, so 2 plus 1 is 3. Remember, the larger one always first, so you don't have to wonder if your signs are correct, and the smaller one second. Again, this is an equation we're solving for 0, so we set each factor equal to 0 individually. And on the other side, d plus 1 equals 0. And then we're solving them independently, so subtract 2 from both sides. This gives us d equals -2. And on the right side, subtract 1 from both sides. So this leaves us with d equals -1. Sorry, I should have canceled these out. Don't want to confuse you. So our solution set for this problem is -2, -1. Both of these answers are correct. And in your packet, this is answer choice A. Okay. Let me take a look at Vanina. If she gives me a sign, everything is good. So I guess we really like factoring. Let's go to the next question. Obviously another factoring problem, but this time it's not an equation. So let's take a look at this problem first. So we do have a coefficient and we have 2 different variables, but that's fine. We deal with that. So first step, if you have a coefficient in front of the squared term, you check if you have a GCF. Let's see, 20, 7, and 6. Do they share a common factor? Nope, they don't. The 7 is a prime number. It only has 1 and 7 as their factors, and 20 is not divisible by 7, and 6 neither. So, okay. That means we have a factoring problem with a coefficient other than 1. The method that I'm using, the Colombian method, states that you multiply the first term by itself, so 20 times 20, and the last term by the first, also by 20. And I'm just going to rewrite my equation. 20 times 20 is 400. I'm bringing down the middle term, 7xy, and then 6 times 20 is 120y squared. Okay, so now I'm doing exactly the same steps that I did in my previous two factoring problems. I'm writing my two empty sets of parentheses. I'm going to square root this first term. So with the x was easy. Now I have to think about two factors that are the same and give me 400. And because here we multiplied exactly by the same, those would be the factors. 20 goes here, 20 goes there, and then x and x. You could check by multiplying these two back together, and you should end up at 400x squared. So remember, the next step was to bring down your first sign, to multiply the signs together to give you your second sign. So a negative times a negative is a positive. And then using this last number, 120, ignoring the sign, and finding the two factors of 120, I have different signs. So the factors must subtract to give me the middle term, which is 7. So which factors of 120 would multiply to give me 120 and subtract to give me 7? Sometimes it's not as easy as it looks, especially if the number is big. So what I did is I came up with two factors that I know for sure. For example, 12 times 10. So if I multiply, I get 120, but if I subtract, I don't get 7. But I can use these two factors to find other combinations. The 12, I can split that in, for example, 3, 4, 2, and 5. And now I can think of any combination of these that would subtract to give me 7. And for example, if I multiply the 3 and the 5 together, I get 15, right? And if I multiply the 4 and the 2 together, I get 8. And you see 15 minus 8 is 7. So these will be my factors. And you can, it takes a little bit, so you can try around. For example, if you had done 4 times 5, that would give you 20, and then you had left the 2 and the 3, that would be 6, and 20 minus 6 is not 7. But dealing with just these numbers limits a little bit the choices that you would have if you just started with a big number like that. So just try to find smaller factors first, and then try to use these numbers to find the actual factors that would subtract to give you 7. Okay, the larger one goes first, and the smaller one goes second, and I don't have to worry about my sign. In this case, it's a little bit special because this one also has y squared. So the same as we did with the x in the beginning, we just have to split it into two pieces. Each number gets a y. The last step, using the Colombian method, because we multiplied by 20 in the beginning, we have to divide by the factors of 20. As you notice, this side is not really divisible by 20 because of 15, and this side is not divisible by 20 because of the 8. But I can split the 20 into 5 and 4, and I can see that this side must get the 5 and this side must get the 4. There's only one way of finding factors. That's why you know you're dealing with the correct numbers. So after dividing, I'm left with 4x, and then 15 divided by 5, 3y, that's my first factor, and 20 divided by 4, so we get 5x and plus 2y. And this is my final answer. I know I was talking a lot and you might be confused now, but later on you can watch it again. Once you understand the Columbia method, it will help you so much because you don't just need it in this class. You will need it in college algebra, in physics, in chemistry, in any other science or math class that you can even imagine. So it's really important for you to learn a factoring method that you got 100% down and you can do with any numbers. Alright, so let me quick check at Vanina. She gives me thumbs up, so I guess we can continue our flight. Let's go to the next slide. Okay, another factoring problem. And in this case, again, looking at it, I see a coefficient of 4 on the highest, in this case, cube term. So I should look for GCF, for the greatest common factor. And I notice that first of all of these share at least one y. So I know I'm going to have to pull out a y. And also if I look at the coefficients, I have a 4, 4, and 80. I'm pretty sure 80 is divisible by 4, so I'm going to pull out a 4y of each term. Dividing each term by 4y. Okay. So after I pulled out my GCF, this is my GCF, I'm left with 4y cubed divided by 4y, leaves me with just y squared. Then 4y squared divided by 4y leaves me with just 1y. And then 80y divided by 4y leaves me with I'm pretty sure it's 20. Just 20. Okay. So after taking out the GCF, I check again and I see that this might be another factoring method, factoring trinomials. So I should try ignoring the GCF for just a second. Looking at this would be a factoring problem having a coefficient of 1. So writing my two sets of parentheses, square rooting the first term, splitting it into 2, bringing down the sign, multiplying the signs together. Negative times negative gives me a positive, and then finding the factors of the last number. Different signs would subtract to equal the middle number, and even if you don't see a number here, there's always an imaginary 1. So the two factors of 20 must subtract to give me 1. Well, 20 doesn't have that many factors. It's either 20 and 2. That doesn't give me 1. And 5 times 4. There we go. 5 minus 4 is equal to 1. Larger number first and the smaller number second. You cannot forget your GCF. Your GCF always is part of the answer. So this would be my final answer in factored form, factored completely. I first took out the GCF and then I used factoring trinomials with a coefficient of 1. And if you look in your booklet, this should be answer choice B. Okay? Any questions on factoring? Okay, let's go to question number 5. So another factoring problem. So you see on this test going to be a lot of factoring. So this factoring problem again is a trinomial without a numeric coefficient, a coefficient of 1. So again, we're writing our empty sets of parentheses, square rooting this first term to split it into 2, x and an x, bringing down the first sign, multiplying the signs together, positive times negative is a negative, and then finding the factors of the last number, different signs in here, so the factors must subtract to give me the middle number. The middle number is 3. So which factors of 28 would subtract to give me 3? The only factors that come into my mind is 7 and 4. 7 times 4 is 28, and 7 minus 4 is 3. Larger number first, smaller number second. Okay, so checking. This is all I can factor, so this should be my final answer. And if you look in your packet, this is answer choice C. And I'm wondering that nobody has asked yet, because this is a question I get a lot, if you are able to switch these two factors around. What, for example, if in the 4 answer choices that you are given was this way? Would that still be correct? Or is this incorrect? So if you are there and you can hear me and you have the option of typing it in, just type if this is another correct answer choice or if this was wrong. I want to see if you guys know that. Okay. Oh, so you guys know. Very good. All right. You guys are split opinions. So let me give you the correct answer. It is correct. These two are equivalent because this indicates multiplication, and multiplication is commutative. For example, if you have 4 times 2, right, these are multiplied, is the same as saying 2 times 4. For both of these you will get the same answer, which is 8. So therefore both of these will be correct, but only one of these would show up in your multiple choice, but you still have to be able to find the correct answer. So if you come up in factored form this way, make sure you find your answer if in the answer key it might show up as this way. Alright, so this time I wanted to do a little bit something different. I'm going to switch over to my co-pilot Vanina, because it actually is a lot talking for so long. So she's going to take over now for the next 5 questions and give us just a quick second. Okay, moving on, we're going to go to question 6. We have 2 linear equations, and that 2 linear equation makes a system of equations. It doesn't specify whether it's supposed to be solved by substitution or addition method. I am going to solve by substitution. It looks easier at this point. In substitution, you normally would pick one of the equations and solve one of them for one variable and plug into the other equations. In this case, we already have it that way. The second one is already solved for y, so the only thing I'm going to do, and I'm going to go on the first one and substitute y for 4x minus 4. Okay, first thing I'm going to do is, well, I really didn't need to use parentheses in this point because it's a plus sign, so I'm just going to go ahead and get rid of those parentheses, and I'll have x
plus 4x minus 4 plus y equals 16. My next step is going to be to collect like terms. I have an imaginary 1 here. 1x plus 4x's give me 5x. I'm going to bring everything else down. Okay, I'm sorry. I guess I'm nervous. There's no y here. Yes, I shouldn't have y because I substituted the y for 4x minus 4. I'm sorry. So I should only have the 5x minus 4 equals 16. If I'm solving for x, my next step should be to get rid of this 4 right here. First, I get rid of the number next to the variable and then the one attached to it. So I'm going to add 4 to both sides. These cancel, so I'll have 5x equals 16 plus 4 is 20. The operation here is multiplication, so I solve by the opposite, which is division, so I would divide by 5 to each side. 5 divided by 5 is 1. I don't need to put 1x, I can just put x. 5 goes into 20 4 times. So I found my first number. Now that I have 4, I can go up here in either one of the two equations and substitute the x. I'm going to go on this one. So I'll have y is going to be equal to 4 times x, which is 4, minus 4. So y is going to be equal to 4 times 4 is 16, minus 4. So y is 12. So I have my y and I have my x. So my final answer is the unordered pair, 412. And your answer sheet is going to be question C. Okay? Do you guys have any questions? No questions? Okay. Let's move to the next slide. Okay. All right, we have another system of equations, and this time it's actually telling me to solve by substitution. I already have one of the equations solved for one variable, so my next step is going to be again to substitute the y for its value, which is, in this case, is 2x. So I'll have x plus 2x equals 3. Combine like terms, imaginary 1, 3x is equal to 3. Multiplication, solve with the opposite operation. So I divide by 3 on both sides, cancel, x is equal to 1. So again, I pick one of the two equations. It doesn't matter which one. I normally go for the one that looks easier to me. So in this case will be this one. So y is going to be equal to 2. I plug in 1 for x. So y is equal to 2. So my final answer is this order pair. In your booklet is going to be answer A. Any questions so far? No questions? Okay, so I'm going to just move on to the next question. Okay, it's asking me to classify whether this system of equation is consistent or inconsistent and dependent or independent. All right, since we used substitution the other 2 times, this time we're going to use the elimination method. So on the elimination method, you pick one of the variables that you would like to cancel. You can either cancel the x or the y. I am going to cancel the x. So what cancels a positive 2x is a negative 2x. Therefore, I'm going to times the first stop by negative 2. And when we do it, you have to do it throughout the whole equation. So I'm basically going to distribute this negative 2 to each and one of them, which is going to give me now negative 2x, negative 6y, negative 16. I'm just going to write down the bottom equation. I have 2x plus 6y equals to positive 16. As you can see, everything cancels. This cancel, that cancel, but they cancel to 0. And on the other side, this also cancels to 0, which means I have a consistent and dependent equation. Every single time that both sides match, this should be a consistent independent equation. If you, for example, had found 0 equals to 3, that is a false statement, which will make the equation inconsistent and independent. Which means you have no solution. Okay, any questions? No questions? Okay, so I'm going to move on to the next slide. Okay, we have a word problem now. I know how we all feel about word problems, but this one is going to be easy peasy. Okay, it's saying that there were 35,000 people at a ball game in Los Angeles. Okay, so also it's saying that they sold $238,000 worth of receipts. And there were some people paid for reserved seats and some paid for general admission. Okay, so I know I have 2 types of people here. So I'm going to label one X and I'm going to label the other type Y. I know if I add these 2, I'm going to get 35,000 people. Also, the other piece of information given is that the people that bought reserved seats, they paid $14 for those tickets at the ball game. So at $14 a piece plus $5 for the people that paid for general admission, that total my $238,000. Okay, we have another system of equations. So again, I'm going to use substitution. So I'm going to solve for one variable and substitute on the other one. I'm going to solve for x on this one. So I have x plus y equals 35,000. If I'm solving for x, I want x by itself. The x is not by itself because of this positive y here, so to get rid of it, I'm going to subtract it on both sides. This would cancel. I bring down my x. These 2 are not like terms, so I cannot combine them. So then I'll have 35,000 minus y. Now I have it solved for one variable. I can just go on the second one and substitute dx for this. I'll have 14x, oops, I'm sorry, 14, open parenthesis, okay, give me a second. Oh, it erased everything. Okay, let me start again. Sorry about that, guys. I'm not familiar with this system. Okay, so I had that x plus y equals 35,000. Then I have that 14x plus 5y equals 238,000. Then I had solved for x, and then I had that x was equal to 35,000 minus y. Okay, that's where we left off. So now I'm substituting. I'll have 35,000 minus y plus 5y equals to 238,000. When I distribute the 14 to both of them, 14 times 35,000 is going to give me 490,000. And I distribute the 14 to the y, I get negative 14y. I bring everything else down. Again, I have two like terms here. I'm going to combine them. I bring down my 49,000. They have different signs, which means I'm going to subtract. I'll keep the sign of the bigger number. So I get a negative 9y. I bring down my 238,000. I'm trying to get rid of this 490,000 so I can have the y by itself. So first step is going to be to subtract this from both sides. This cancels. I'm left with negative 9y on this side. 490,000 is bigger, so I'm going to keep the negative sign, and from subtracting those I get 252,000. I need to get rid of this negative 9. Again, this is a multiplication. I solve with the opposite, which is division. So I divide by negative 9 on both sides. This cancels the 1. I don't need to put the 1. Negative and negative is positive. It cancels. So my final answer is 28,000. I guess I use all the space. Okay, I think I could just use this little space right here to finish this. Now again, I'm gonna plug in my y. I guess I could just plug it in right here. It'll save space. I use this space right here. So x is going to be equal to 35,000 minus 28,000. So x is equal to 7,000. This is my ordered pair. So basically, X was the reserve seats. So 7,000 people paid for reserve seats, and the Y were for general admission. So 28,000 people paid for general admission. In your booklet is going to be answer A. Okay? No questions? Okay, so let's go to the next slide. Okay, so we have here a perfect cubed on one side, a perfect cubed on the other side, separated by a negative sign or minus sign, if you will. This calls for a difference of cubes. Let's pull out the formula. So this is the general formula for difference of cubes. AB plus B squared. Okay, there's also the sum of cubes. If, for example, you had something like this, x cubed plus 343. Then you would use this formula, A plus B, A squared minus AB plus B squared. If you notice, if you start with a minus, the first one's going to be a minus. This one is going to change to the opposite sign. If you start with a plus, now this one changes to a minus. But the formulas are very similar. So in this case, the way you solve this is to figure out your A, you cube root the first term, then you cube root the second one. The cube root of x, it cancels out, so the cube root of x is just x. So in this case, your A is x. And the cube root of 343, I'll suggest you do the factoring tree of 343. I know that 7 goes into 343 if you do the division, and it goes in 49 times. 7 times 7 gives me 49, and that's where I get the cube root of 343, which is 7. So my B would be 7. So I have my A and my B. I'm going to substitute in the formula. So I'm going to have x minus 7, a squared, so in this case would be x squared, minus ab, which is the same thing as a times b, so 7 times x would be 7x, plus b squared, b is 7, so 7 times 7 is 49. And that is my final answer. In your booklet, it will be answer D. Any questions? Okay, I guess you guys are in tip-top shape for the final exam. And for the test review too, of course. Okay, so if you don't have any more questions, I'm going to go ahead and pass the ball to my captain. Thank you for listening and keep enjoying your flight.
This is your captain again. I need everybody to return to their seats and fasten their seatbelts. We're expecting some turbulences. So we are going to go to question number 11 now, which is another question about systems of equations. And we are supposed to solve this by using the substitution method. Well, I'm seeing fractions, and most of us do not like fractions, but I would suggest before we focus on the system of equations, we're just going to get rid of the fractions. by using the method of multiplying by the least common denominator. So if you look at the very first system, if you look at the denominators, which is 8 and 5, the least common in this case, and I'm going to let you guys answer that because I know you guys know that, what is the least common denominator of 8 and 5? Because I think some of you might already fell asleep. So what is the least common denominator of 8 and 5? Help me out here.
40. You're saying 40.
Okay, good job. 40. That's right. So we're going to multiply each term by 40, and we can make it a fraction as well, 40 over 1. And we're multiplying it by the first term. Then also we are multiplying the 40 over 1 by the second term, which is y over 5, and by the last term. So in this case we don't need a fraction because the 1 is not a fraction. Now let's rewrite our first equation, and before we straight multiply we can cross cancel. I see the 8 and the 40, they have a common factor of 8, so the 8 goes into 8 1 times, the 8 goes into 40 5 times, and over here too we have a common factor of 5, so the 5 goes into 5 1 time, the 5 goes into 40 8 times, and over here nothing cross cancels because there's no denominator. Let's straight multiply together our leftover numbers. So we have 5 times x gives us 5x, and then we have negative 8 times y, so we get negative 8y, and over here 40 times 1 is just 40. So no more fractions. And let's do the very same thing with the second equation. In this case it should be easier to find the least common denominator because there's only one fraction. So what is it? Wow. Thank you, Deborah. 6. Very good. So let's do the same thing and multiply the system by 6. And I showed you guys in the first equation how to actually use the steps. So here I'm going to do it quicker. I'm just going to make myself a little reminder here that I'm multiplying every one of them by 6. And then the first one is 6, and the 6 will cancel out to be just 1. And then I'm rewriting my problem. So I got x minus right here 6 times y, so 6y, and then 5 times 6, which is 30. Okay, so now we have no more fractions, and we are supposed to use the substitution method. So right here I see my x variable all by itself, so I'm going to use this equation to get x by itself. I'm moving 6y to the other side by adding 6y to both sides. That leaves me with x equals, this side cancels out and these are not like terms, so I'm just going to write them next to each other, 6y plus 30. So now I can substitute this into the first equation for x. So my first equation is 5, and then I have the x, so I'm going to plug in 6y plus 30, and then I continue with my equation. I have minus 8y equals 40. All right. Using distributive property to get rid of the parentheses, right here, distributing the 5, I get 30y plus 5 times 30 is 150, and then I bring down the last term, 8y, and all that is equal to 40. Remember, our goal is to solve for y, so I see two like terms here. Let's combine these two. 30 minus 8y is 22y, and let's bring down the leftover terms. It's all equal to 40. Okay, so focus, we're solving for y. In this step, we are going to subtract 150 from both sides. So let me write it here, 150 from both sides. This side cancels out. We are left with 22y, and that is equal to 40 minus 150 should be a negative answer because the larger one of the two is negative, and it is 110. Okay, last step. Divide by 22 on both sides to get y by itself, and y equals negative 110 divided by 22 is negative 5. If you don't know it, you can do your side calculation or you can use a calculator, but we are not focusing here on dividing numbers. So our y equals negative 5. We are not finished yet. We only found our y coordinate of the point that the two lines are crossing. We still have to find our x. So we go back, and I probably would look at either one of these two equations because the original ones were fractions to plug it back in. I'm going to choose the second one because the numbers are smaller. So I'm going to use x minus 6y equals 30 to plug in my negative 5 for y. So x minus 6 times negative 5 is equal to 30. X, okay, a negative times a negative is a positive. 6 times 5 should be 30. Okay. And then I'm subtracting 30 from both sides. And I get x equals 30. Take away 30 is just 0. Okay, so writing this as a point, I am getting 0 for my x value and negative 5 for my y value. This is the point where the two lines on the coordinate system cross. And in your review packet, it should be answer choice D. Are there any questions? Vanina, you answered all of them. Okay. Then let's move on to question 12. Oh, my favorite, another factoring problem. Yay. Okay, in this this time I see 4 terms. Remember, so far we've been dealing with 2 terms and 3 terms. So now we have 4 terms. 1, 2, 3, 4. First step is to look for a GCF. So look at the coefficients, look at the variables. Is there anything they have in common? They don't all have an x. This one is missing an x, so x is not a GCF. And I'm looking at 12, 18, 10, and 15. Well, these two have 2 and 5. I mean, no, the 15 doesn't have 2. Okay, almost, nope. I don't see that they have anything in common. I don't see a GCF. So when I have 4 terms, what I do is I'm going to cut them in half, and I cut them right here in front of the sign. The sign still belongs to the 10. And then I'm just going to focus on my left side, and I'm going to pull out the GCF individually from each side. So now looking at 12x squared and minus 18x, the GCF of both of them would be a 6, and they also share an x. So I divide each term by the GCF to find my leftover numbers, and that leaves me with 2x minus 18 divided by 6 is 3, and x over x is gone. Okay, once I did my left side, I'm going to focus on the right side, and again, looking for my GCF, I have 10 and 15, both of them are divisible by a 5, and because this one is a negative, this sign must go down, so a negative 5. I'm dividing each term by a negative 5, and I'm left with negative, and a negative is a positive, so positive 2x, and a positive divided by a negative is a negative. 15 divided by 5 is 3. Okay, so these two must exactly be the same when you're using the grouping method. This is grouping. If they are not exactly the same, you should go back and check. You must have made a mistake. But if they are the same, you can regroup the problem and you bring down the factor they have in common, and you regroup the leftover numbers, which is the 6x and the negative 5. So 6x minus 5. This would be this problem in factored form. And if you look at your packet, this should be answer choice B. Questions about grouping. Remember, you use the method of grouping, the factoring method of grouping, when you have 4 terms. Okay. Another factoring problem. This time we have 2 terms, and we are tempted to think this is the sums of cubes, but if you really look at it, I cannot think of a cube root of 3. You cannot split the 3 into 3 equal factors. When you multiply them together, you get 3. So this is not the sum of cubes. But I could always try to pull out the GCF. This is the number 1. You should always look for GCF, greatest common factor. And in this case, I see that both of them have a greatest common factor of 3. And also, they both have at least 1x. So I'm going to pull out 3x. Divide each factor by the GCF by 3x, and you are left with 2x over here. You had 3, you take out 1, 2 left. And over here, you are left with just 5. You had an x, you took 1 away, it's gone. So this is your factored form of this problem. You always could check if you can factor more, but I know that this is not another factoring method. Again, when you see a plus sign, 2 terms, it could be the sum of cubes, but this is not a cube, 5 is not a cube, so this is it. And in your review packet, this is answer choice A. Okay. Giving you a few seconds to digest the information, and let's move on to question number 14. Okay, so this is another system of equations, but in this case they want us to find a solution and then explain what the solution means. So first let's focus on solving the system of equation, and then we're going to go through the answer choices. It says by substitution, so again I'm looking for a variable that's already by itself. Right here I see 1, so I'm going to solve for y. If I solve for y, I move the 3x to the other side, and I'm left with y equals negative 3x, the sign changes, and plus 14. So I'm going to take this y and I'm going to plug this into the second equation for y. 12x plus 4, I got negative 3x plus 14. And then I continue with my equation, plus 4. Wait, what am I doing? Okay, sorry, I got sidetracked. Let me erase this real quick. Okay. And back to pen. A bird just hit my windshield. So no worries, we are right back on course. So we plug this into the second equation for y, and we continue with our route to our destination equals 56. So now we're solving for x using distributive property to get rid of parentheses. So 12x, positive 4 times negative 3x is a negative 12x. And then 4 times 14, you can use your calculator. I believe it's 56. And all that is equal to 56. Okay, I don't know if you can see what I can see, but this pretty much looks like that these two are the same. So I have 12x and I'm subtracting 12x. That would already give me 0. And then over here 56 equals to 56. So this is a true statement, correct? This is a negative statement, Vanina? No. This is a true statement. And if you have a true statement, what that means for systems of equation, you always have to think about it in the perspective of graphing. That means that every single point from one line is also a point from the other line. So if you have a coordinate system and there's one line, and I did not properly graph the line because I did not solve it to graph it. So, but I just wanted to show you guys, if you have one line, the second line would be exactly on top of the other line. So we definitely would have a solution, and in this case we would have infinitely many solutions because every single point from one equation would also be a solution from the other equation. So our correct answer in this case would be B, infinitely many solutions. And any system that has a solution, whether it's one solution or infinitely many solutions, it's always a consistent system. But in this special case, when you have one line on top of the other line, those lines are dependent. That's why it's B. If we look at choice C, there's another one that also says infinitely many solutions, but in this case it says inconsistent, and this is a not true statement. Any system that has a solution is a consistent system. Okay, are there questions? I really need you guys to get this down about consistent, inconsistent, no solution, solutions, because I believe there's at least 2 or 3 questions on your test that deal with these kind of questions. So let me just say it one more time. I hope you guys copied all this. I'm going to erase it real quick. You have, when you're dealing with systems of equation, you have 2 options. You could either have no solution, or a solution. Solution. No solution means that these 2 lines are parallel, and solution means that either the 2 lines are crossing or that the 2 lines are exactly on top of each other. Then when you have no solution, it is always inconsistent, and if you have a solution, either one of them, it's always consistent. Consistent. By knowing this, you can already limit your answer choices to at least 2. And then we have to continue with the versions where we have solutions. If we have one single solution, this one here, it is a independent system. Independent. And if the 2 lines on top of each other, and this might make sense, they depend on each other. Every single point on one line depends on the other line because they are on top of each other. So this one is a dependent system. Dependent. So I hope this clarifies a little bit Okay, Vanina just mentions that I should put a point here. So this is where they're crossing. This is most of the time what we're finding when we have one number as a solution. It is the point where the two lines crossing. So I hope this clarifies a little bit all these terms that are given in the answer choices. Okay, moving on to the next question. Question number 15. You're welcome, Deborah. Vanina just gave me thumbs up. Okay, so question number 15, using substitution again. I hope you guys are not sick of substitution yet, but in front of you, in your seat, there should be some brown pockets in case you feel nauseous. Okay, so substitution. In this case, we have a lot of single variables, so the choice is to us. I could pick any, so I am going to pick, I'm going to pick this one. Actually, I don't have to solve. Look, on this side, they're already all by itself. So I'm really lost here. I don't know which one to pick. Can you guys help me? Please choose which one I should focus on, which variable I should pick to substitute in for.
Somebody said I picked the second one.
The second what? The second one, X or Y? So I'm going to pick the second equation. Back to my pen. I'm going to pick the second equation to plug all this in for X in the first one. So Y plus 8, and then continue with the equation, -3 equals Y. Okay, solving for Y. Using distributive, no, we don't really have anything to distribute here. This is just two separate things separated by a subtraction sign, which we can actually drop the parentheses. There's no distributing going on here. And then solving for Y, so combining these two, 8 minus 3 should be 5, and plus Y equals Y. So then I'm solving for Y, so I'm going to bring my Y over to the other side. And on this side, Y is gone. We have 5. We have a positive 1. Remember, there's a positive 1 in front, and here we can imagine there's a negative 1. So these two cancel out to be just 0. And now 5 equals 0. Well, in math, that's not true. So what does this mean pertaining a graph? How would you describe the graph? Tell me, are those parallel lines? Are those lines that crossing at one point? Or are those lines that are on top of each other? What do you think this solution means?
Christine says it's parallel.
Okay, somebody says it's parallel. Does everybody else agree that these two are parallel lines? Okay. Do we need to turn on the light in the airplane so our customers are waking up again? But Christine is right. These two lines are parallel, which means there is no solution. They are never ever going to cross. So let's look at our two options that say no solution. No solution. Right here, A and C, and then we have inconsistent and consistent. So on the previous slide, I told you that no solution is what? It's always inconsistent or always consistent? All right, we agree on this. Inconsistent, that's correct. So our correct answer choice in this case is A. No solution and inconsistent. Very good. So I'm really exhausted of flying the plane here. I'm gonna hand the steering wheel over to my co-pilot, Vanina. Just hang on tight.
Okay, hello there again. I hope nobody's afraid of heights. We are now on descending mode. We're almost done. We still have about 10 questions. Yes, it's 25 in a total, so okay, let's go to question 16. Okay, so we have 3 equations. I'm gonna do them one by one. I'm gonna need all of them to be in y equals mx plus b form. I'm just gonna pretend it's an equal sign, and at the end I'll do whatever I need to do with it so we can solve this. Okay, let's go with the first one. So we have 2x plus y is greater or equal than -1. I need to solve for y, which means I'm going to start by subtracting 2x from both sides. This would cancel, so y is greater or equal to -2x minus 1. Okay, I guess I'm just going to go ahead and graph it, and maybe I'll use different colors for all the other different ones. So my y-intercept is -1, so I would start right here. And then my slope is -2. I'm going to put it over 1. So I have a rise of -2, which means I'm going to go 1, 2 down, and then a run of 1, which means I go 1 to the right. I'm going to just do it again. 1, 2 down, 1 to the right. 1, 2 down, 1 to the right. So, I'm going to do this. Okay, so it looks, ooh, that is crappy. Yeah, my straight line is not so straight, but something like that. And it says greater or equal, which means I shade above the line. Something like this. All right. Now, let me change colors real quick. In color, I'm going to do the second one, blue. Okay. So, same thing. I'm going to put this one in y equals mx plus b form. I'm going to do it right here on the side. Where else? No, I have space. I'll do it down here. So I have y minus x less or equal than 1. I need to solve for y. I'm going to add x to both sides. Okay, so then I have y is less or equal than x plus 1. Okay, same thing. Let's graph it. My y-intercept is 1. So this is my starting point. And then my slope is, there's the imaginary 1 over 1 right here. That means I want 1 up, and 1 over. I'll go 1 up, 1 over, 1 up, 1 over. So I combine my points. Woo! Talk about straight line. Okay. All right, let's all imagine that that is a straight line. Okay. So it's less or equal. So that means I shade. It is. I shade below the line. man. So ashamed right now. Okay. Then I have as x is less than 2. So like I said before, first I imagine that this is an equal sign, right? Which means x is equals to 2 is a vertical line at 2. Let me use a different color here. Feel like we're in Brazil. February Carnival. Okay, let me pick, I don't know, maybe green? Okay, green is good. So then I'm going to make a straight line in quotes. Oh, man. Yes. Okay, so this one, wait a second. Give me a second. Let's go. Use my eraser. This says, since it said less than, just less than. If it had the little dash below it, which means less or equal to, I would use a full line, a solid line, but since it's just less than, it's supposed to be a dotted line. So let's do this. I erase it. We do it again. In color. Okay, so it's supposed to be something like this. Whoop, whoop. If that's not straight, then I don't know what is. Okay, there we go. Oh, excellent. Okay, same thing. It's less than, so I shade to the left because all the numbers that are less than 2 are to my left. So let's do this. I hope you guys are having as much fun as I am making these straight lines. Ah, there we go. Okay, so now looking at the graph, the intersection is, I'm going to do it with a different color so you can see it. Yeah, let's see, maybe black. All right, it's right here. That's where all 3 colors meet each other. So this is actually my answer. Does that look good? Okay, I think so. All right, so in your review answer sheet is going to be answer B. All right, looks good. All right, next question. If you don't have any questions, let's move on. No? Okay. All right, we're going to jump to factoring. All right, so it is important for you to be able to identify what type of factoring you should be doing. In this case, it's telling you by grouping, but just the fact that you have 4 terms indicates that grouping would be the best way to factor this. What I do, or what we do, is we cut it in half right before the second sign, and we find GCF for each of them separately. So the GCF here, I see they share an X, and they also both have a Y in common. So my GCF is XY. XY. So I write it down, open 1 set of parentheses, and divide. This cancels to 1. Be careful. This does not cancel to 0. Any number over itself, it's 1. So same thing. Every letter over itself, it's a 1.
Somebody mentioned we don't have an X in front by the 4.
Oh, I just noticed we don't have an X by the 4, so my bad. I guess the GCF is just X. Hold on. Forgive me, guys. I'm afraid of heights. This is messing up my mind. I'm flying. All right, in color, black. All right, I like the, oops. All right, let's try this again. All right, the cut in half before the second sign, GCF, Y. They both share Y, and that's it. So which means my GCF is y. I open a set of parentheses and I divide. Cancels. I'm left with an x right here. The y's cancels. I'm left with a negative 4z. Okay, I bring down my sign. That should be my first step when I go to the other side. They both have in common a 9, and that's pretty much it. So 9 is my GCF. Go back to normal. I open a set of parentheses. The 9's cancel. I'm left with an x. I bring down my sign, or I could just say negative and positive in division and multiplication is negative. 9 goes into 36 4 times, and I have that z up there. So as I can see, these two match. So I could just factor it out again as a GCF, right? Like this. And then if that's a GCF, that means I'm dividing each term by the GCF, which means this cancels. I'm left with a y, and this cancel, and I'm left with a 9. So this is my final answer, and that's letter D for you. Okay, in your booklet, it appears that you have a y plus 9 first and then x minus 4z, but as we discussed earlier, it wouldn't make a difference because we are talking about multiplication. 2 times 3 is 6. 3 times 2 is still 6. Any other questions? Actually, any questions at all? None? Okay, let's move on to the next question. All right, we still factoring. Don't be alarmed. Big numbers, they mean nothing to us. We got this. Okay, so the first thing you notice, well, I've noticed, have you noticed anything special about this trinomial? Does anybody notice anything special about this trinomial? No? Okay, I'm going to tell you what's happening.
Two perfect squares, all perfect squares.
Yes, yes, yes indeed. Okay, I have a perfect square here, and then I have a perfect square here. If I square root this, and I square root this, and I times by 2, and I get this middle term, then this is a perfect square trinomial. So there's no doing Columbian or grouping and wasting time. It's going to be super easy. So the square root of 81x squared is 9x. The square root of 25 is 5. So if I times them together and times by 2, I get this term here. This is a done deal. So 9 times 5 is 45x times 2, that's 90x. Excellent. That's it. This is a perfect square trinomial, which means my answer should be, it's going to be something like this, squared. I bring down my sign. I square root this. I put it here. Square root of the other side, I put it here. And that's just like that. This big number who tried to scare us, not intimidating at all. Any questions on this? Oh, by the way, on your booklet, that's answer B. Any questions? Okay, so I'm going to move on to the next question. All right, we have a word problem. One number, I'm going to be original here and call it X. Okay, I was just being sarcastic. X is our go-to letter. Okay, one number is means is normally represented by the equal sign. 5 less than a second number, which means is 5 less than this second number, which I'm going to call y. Then Okay, we're going to have to make another equation for this because it's not going to work if you use this information in one equation. So my second part would be twice the second number. We said the second number was y, so twice, 2 times, is, again, we use equal sign, 2 less than 5 times the first one. Does anybody understand what I did? Is there any question on that? No? Okay, so I'm going to move on. So we end up again with a system of equations. Yeah, we're going to do substitution. Again, I hope you don't have a problem with substitution because it's the easiest step at this point since this is already solved for one variable, which means all I have to do now is whatever I see x, I just plug in this whole thing right here. So I'm going to have 2y equals 5. That's my x, which I'm going to have to substitute for this, and that's that. I need to get rid of parentheses. These two are not like terms, so my only other option is to distribute the 5. So I have 2y equals to 5y minus 25 minus 2. Combine like terms right here. I get negative 27. I bring down everything else. That's a y. Do not get it confused with a 9. I almost got confused, so that's why I'm saying that. Okay, I'm still combining like terms. These two are not on the same sign. The only thing that cancel a positive 5y is a negative 5y. So I'm going to subtract 5y from both sides. These two cancel. I get negative 3y equals negative 27. Again, this is multiplication. I solve with the opposite operation, which is division. These cancel, so y is equal, negative and negative is positive, so y is equal to 9. I found my y. Then I'm going to do this little detour over here and substitute for y up here. So 9 minus 5 equals to 4. So x is 4 and y is 9. So let's see if this is right. One number is 5 less than a second number. Yes. 4 is 5 less than 9. Twice the second number is less than 2 less than 5 times the first. Really? No. I guess that's self-explanatory. We're just going to move on. No, I'm just kidding. I'm going to explain it to you. Okay, if you plug in y here, for example, so that's the second part. So I have 2, my y is 9, right? Equals to 5, x is 4. This should be a true statement. If it's not, that means this is not right. So that's 18, right? Where am I? Okay, equals 5 times 4 is 20 minus 2. Yep. We are good. And that is answer letter C on your review booklet. Any questions? No questions. Okay. Proud of you guys. Okay. Question number 20. Okay, we have one more system of equation. It seems like it's big on your review. Just to spice up things, we're not going to do substitution. We're definitely going to do addition or elimination method on this one. Okay, let's say we're trying to eliminate the x. So all I have to do is times by -1 to the entire thing. So I'll have negative x, negative y equals to positive 2. So then I'm going to just rewrite the second equation right below it. And 2 minus 1 is 1. No, I'm sorry, negative 1. I'm not adding yet. Okay, so that's that. Now I'm going to add. Wow, they cancel again. This cancels, that cancels, but to 0, 2 minus 1 is 1. That is completely false. 0 is never equal to 1. So, for your answer is C. Inconsistent. That's no solution. Because 0 is not the same thing as 1. All right, I'm going to go on, what do you call it, autopilot? Do you guys feel safe if you go on autopilot mode? Okay, I guess not. So I'm going to hand it over to the captain.
This is your captain speaking. I just wanted to let you guys know that we are on flight schedule. I mean, we're having some rain showers, but that should not stop us from landing on time. So let's move on to question number 21, which obviously has to do with systems of equations, but this time we are actually given a possible solution. So it's suggested that the solution of this system is -5, -4. There are multiple ways of solving this. What I'm going to do is I'm going to choose to plug in my point first into the first equation, see what happened, and then into the second equation to prove if it's really on the line. So this is my x value and this is my y value, and I'm taking 3x plus y equals -11, and I'm plugging in my x value, which is -5, plus my y value, which is -4, and that must be equal to -11. So let's check if that is true. 3 times -5 is -15, and then positive times negative is a -4 is equal to -11. Now, -15 minus 4, you are tempted to say it's 11, but remember you're adding into the negative direction, so that would be -19, which is definitely not equal to -11. So that means that this point is not on the first line. For example, if the line is here, that point will be somewhere here. So if it's not on the first line, that it cannot be a solution of the system, so we can stop right here. But if, for example, you would have gotten a true statement, then you would have to do the same thing to the second equation and see if the second equation also gives you a true statement. But as soon as you get a not equal to, then this is not a solution. Not solution. And let's quick check which letter is that in your packet. That should be answer choice A. No solution. Not a solution. Okay, if there are no questions, then let's move on to question number 22, which is another word problem. Don't be afraid of word problems. Sometimes even myself have to read word problems multiple times to really understand what the problem is asking for. So let's read it first. The Family Fine Arts Center charges $23 per adult and $10 per senior citizen for its performances. On a recent weekend evening when 458 people paid admission, the total receipts were $6,218. how many of the people who paid for senior citizens. So how many were senior citizens? Well, let's underline the most important information first. We have $23 per adult, $10 per senior citizen, and then we have 458 people paid admission, and the total receives were 6,218. So because we are in the section of systems of equations, we should come up with two equations. We can use the first equation to just add the total number of people. So let's call our adults X and our senior citizens Y. So then when we have our adults and we're adding the senior citizens, we should get the total number of people that paid for admission. That will be our first equation. And then the second equation, we can try to figure out how to come up with the total amount of money we made, and that would mean that we take the amount they charge for the adult tickets, which is $23. So $23 times the number of adults that paid plus the amount they charged for senior citizens, which is 10, times the number of senior citizens that came to the performance, and that should equal to the total money they received that evening, which is $6,218. So we have our two systems of equations, and looking at it, I probably will go for substitution. So I'm going to solve for X right here by subtracting Y from both sides, and that should equal X negative Y plus 458. All right, so now I'm going to use this and plug that into my second equation for X. 23 negative Y plus 458. Continue with your equation, plus 10Y is equal to 6,218. Okay, using distributive property to get rid of the parentheses, I am getting negative 23Y, and then 23 times 458. Let me see, this should be a positive 10,534. Let's bring down the 10Y, and all that is equal to 6,218. Okay, combining like terms on each side, right here, these two. So negative 23Y plus 10Y, that should be a negative answer, negative 13Y plus 10,534 equal to 6,218. Okay, moving my 10,534 to the left of the equation and subtracting these two numbers, I should get negative 13Y is equal to, I should get a negative answer, 4,316. Okay, and then last step, divide by negative 13 on both sides. And thanks God they invented calculators. So this should be a positive 332. If you notice, the question was how many of the people who paid for were senior citizens. And we called our senior citizens Y. So this number represents our senior citizens, which means we are done. We actually do not have to solve for x in this question. And if you look at your review packet, this is answer choice A. But if you wanted to go further and now where you already did half the problem, you really care about how many adults came to this performance, you can go ahead and plug this into either one of the original equations, either this one or that one. And if you do that, you should get for the adult tickets, you should get 126, just in case to check yourself. This should be the adults that came. Adults. All right. If there are no questions, we're moving on. Okay. This is a good one. And I also, you might think this is an easy question, but I have to warn you, this graph is only given here and in your review. But on the actual test, you will not be given a graph. So you actually will have to figure out the system of equations graphically. And what we're going to do is to be able to graph it, and I'm going to show it to you guys in a minute how to graph it on the calculator. But before we can type it into the graphing calculator, we have to solve both equations for the form y equals mx plus b, which is the slope-intercept form. So both of the equations we're going to have to solve to have it in this form. Let's start with the first one. The first equation is x plus 4y equals negative 23. So we're going to solve for y, subtract x from both sides, and then minus 23, and then divide by 4 each individual term. You are left with y equals, and you can make it a fraction. Remember, there is imaginary 1 in front. If this looks better for you, it's fine. And 23 over 4. Remember, you always have to check if you can reduce fractions, but 23 is a prime number, so this is all you can reduce. This would be our first equation, and now let's solve our second equation. The second one is 4x minus 4y equals 8. So solving for y, subtract 4x from both sides. You are left with negative 4y equals negative 4x plus 8. And then dividing by negative 4, dividing by negative 4, and one more time dividing by negative 4. This leaves us with y is equal to negative 4 over negative 4 is just x, and positive 8 divided by negative 4 should give me a negative 2. This is our second equation. So now remember those two equations. I hope you wrote them down, because what we're going to do is I'm going to switch my screen real quick, and you can get your graphing calculator. I hope you have it right next to you. Okay. Oh, I should have kept the ink. Oh, never mind. Right here. So this is the TI-84 Plus Silver Edition, but any other calculators, the TI-83, should also work and should look similar. What you're going to do is you have your two equations. Like I said, I hope you wrote them down. And to graph, you will start with this bottom here, which says y equals. Okay. So then this window pops up and you have a bunch of y's here, so you can type in multiple equations. I'm going to start with the first one, and that one was negative 1 over 4x, 1 over 4x, and then minus 23 over, and you can use the division sign as the fraction bar, over 4. This was my first equation. I can either hit enter or the down arrow to get to the y2. And now I'm going to type in my second equation, which is x minus 2. All right. I have my two equations, and sometimes you're messing around with your windows, so you could use the window option to double check that your window is on the standard window, which is negative 10, 10 on the x-axis. It's counting by 1, and negative 10, 10 on the y-axis, and it's counting by 1. So the window is good, and we can then hit graph to see our graph. And I can put my large screen here. So this is the graph that you are shown, and right here I see the intersection point that I was supposed to find graphically. So what I do is I'm going to use the button, let me put back on my key. So I'm going to use the button second, and then right here you see how it says in blue calc over the trace. You're going to click right there. And then option number 5 says intersect. So you either can use the arrows to move down to option number 5 and then hit enter, or you can just hit number 5. So now it asks you for the first curve. This is if you have more than 2 lines in there, so it asks you for which lines do you want to find the intersection. So you can just hit enter. This is my first line, my second line, yes. Then it asks me if I wanted to guess. Okay, guess for me. So now it gives me the intersection of negative 3, negative 5. Let me make my screen larger so you can see it. So my x value of this intersection is negative 3, and my y value is negative 5. So like I said before, you will not be given the graph like you see it on my slide or like you see it in the review. On the actual test, there will not be a graph. You actually will have to find it on the graphing calculator and then compare this point, negative 3, negative 5, with the answer choices. So let me switch back to my PowerPoint. Right here. So you will have to find the answer choices, and in your review packet this would be a B. So negative 3, negative 5, which is right here. Are there questions about how to use a graphing calculator, how to find the solution graphically of a system of equations? Okay, no questions? Then let's move on to question number 24. This is another factoring problem. So I have two terms. Two terms usually indicate the difference of two squares, can be because difference means subtraction sign, or it could be cubes, and it doesn't look like cubes neither because this is a 2, not a 3. So I'm going to go with looking for greatest common factor. Greatest common factor. Both of these have x in common. And I'm going to take out that x, the GCF, from each term, and I'm left with x plus 3. All that is equal to 0. Whenever you have something equal to 0 and it has to do with factoring, you take each part. In this version, the x in front is a part, and this is a part, and each part you set equal to 0. So the first part is already solved for x, and then the second part, you will get x by itself, so subtract 3 from both sides. And then you get x equals -3. So usually the highest degree of the polynomial, in this case is 2, gives away the number of answers you should get, and in this case 2, 0 and -3. And if you write it as a solution set, usually the solutions are in descending order, so the smallest number first and then the greater number. So this would be the solution set of this factoring problem. And this one is solution A. Okay. Now, are there any questions on factoring? Because I see Vanina typing away. Okay. So question number 25 and last question. I promised you guys we're going to land on time. So last question is an elimination problem. And as you can see, this one is already set up for us. We do not have to multiply by anything. This one is a positive y, this one is a negative y. So if we add down, then this one is the variable that cancels out. And here, remember there's an imaginary 1 in front of the x, so we have 1 plus 1 makes 2x. This canceled out to be 0. I don't need the 0. And 8 plus 4 is 12. Get x by itself, so divide both sides by 2, and then x equals 6. So we found the x value. Let's go back, pick either one of them. I'm going to pick this one with the smaller numbers and plug in my x value. So 6 minus y is equal to 4. I get y by itself. So subtract 6, negative y equals, I'm getting a -2, divide by a -1 on both sides to get rid of the negative sign in front of the y, and y is equal to +2. So my solution to this system is 6, 2, which is D. Now please put your trays down and fasten your seatbelt and put your chairs in straight position. We are going to land now. So I have one more slide prepared as the last time to give you all the information about test 2. Me and my co-pilot Vanina will stay tuned for a little longer to answer individual questions about test 2 or any other concerns you have. You can either type them or ask us to unmute your microphone if you actually wanted to talk to us. So we're going to stay on until everybody's question is answered. If you do not have any more questions, thank you so much for flying with us today. I hope to see you again and have a good day. So for everybody else that wants to stay tuned and has more questions, this is test 2 info. So this is the information about Osceola Campus Testing Center. Remember, if you were allowed to take it on a different campus, you are responsible to find out the hours of operations for that particular campus. Sometimes they have different hours of operation. The test will be open from February 27 to March 6. The last you can take it is 5 p.m., which means you allotted 2 hours. You should be there 2 hours before 5, so the testing center will allow to take you the test, which means 3 p.m. the latest that you will have to arrive at the testing center if you're waiting until March 6, which is a Friday. Then things you should bring, make sure you bring your graphing calculator, obviously pencils, your VID or photo ID is very important. I had a student for test 1 that did not take his test because he did not provide the testing center with a photo ID, so he wasn't allowed to take his test. Make sure you bring a valid VID photo ID. Then this is the CRN of this class. Sometimes the testing center asks you for this information, which is 22524. This is MAT1033C, Intermediate Algebra, and I'm the instructional assistant of the course, Diana Budach, and I was the one submitting your test referrals, so my name possibly is on there. They might ask you for that. Again, here is the hours of operation, and I hope this test review was helpful. If you participated today and those questions seemed easy to you, there's nothing to worry about on the test. Questions will be similar, possibly different numbers, and for example, if we were discussing the sums of cubes, there could also be a possibility that you might get the difference of cubes on your test. But anything else should be all expected. There is nothing on the test that you have never seen before or that wasn't discussed in this test review. So I'm done. You can continue asking questions to Vanina. Vanina, is there anything you want me to answer? No? Okay, so I guess she answered everybody's questions.
To the best of my abilities, yes.
To the best of her abilities as a co-pilot. Thank you, Vanina, for flying with me today. It's always a pleasure. You did great.
It was a great day.
Okay.
Signing off.
So I hope everybody has a great day, a great week. And this is your captain, Diana. Hope to see you soon. Have a good day. Auf Wiedersehen.